So I came across an issue the other day while I was chatting with my sales data using OpenAI's Chat GPT-4. And that was, I was asking it some rudimentary questions about my data, and some of the answers were correct, some were not. So I had to dig down deeper to figure out why. But I thought that made for a great example for the importance of validating your data in AI before you go any further with it, like doing deep dive analysis or trend analysis or generating charts, etc. Let me show you what my architecture is here. So I'm doing a project where I'm exporting data from a data warehouse into CSV files. So those files are available for users to chat with using their AI tool. In this case, it's OpenAI's ChatGPT-4. Now, in this example, I have 1 million records of sales data. So this is real data. It's not from Kaggle or GitHub or anything like that. It's actual data from a data warehouse that I'm dumping into a CSV file, and then I'm importing it into ChatGPT and conversing with it. That's the ultimate goal. But before I go any further with that, I need to make sure it's not hallucinating and it's looking at this data set as it should. So let me bring up the SQL Server that I have. So I have a data warehouse here, and I have a table called sales. This is denormalized data. My data warehouse is a star schema designed architecture. So it's the sales data initially is in a fact table with integer lookups. I'll show that a little bit later. But anyways, I have the data here, 1 million records, 10 columns, and just a disclaimer here that these sales reps, the cities, even the states are all, well, the states aren't fictitious, but the cities are, the sales reps are. It's all fictitious data, so I'm using that. I've converted that, or as I like to call it, obfuscate the data to maintain the privacy of the data before I upload that into an AI tool that's on the internet. So with OpenAI, if the enterprise licensing, it's SOC compliant, so the security's there. They also say they don't train on that data. Now, whether you're comfortable with that or not, you can do something like I did here. So when you see these names here, actually I had AI help me translate that to give aliases to the real sales rep names. So these are not real names here. It's all fictitious. So here's my data, and I'm just going to create a simple metric to give me the top 10 parts by quantity sold. Okay, so this gives me something that's pretty straightforward that I should be able to ask the AI and see how it's thinking and what values it brings back to me. So let's do that. Let me bring up OpenAI. Let's see. First, I want to show, this is the CSV file, by the way. So I've taken it from SQL Server, the data, dump it into a CSV file, and it's that file that we were going to use to upload to OpenAI. And here it is here. So 10 columns, 1 million records. That's what we're about to upload. So let me shut that down. Let me bring up OpenAI. Here's ChatGPT-4. The only difference, well, not the only difference, it comes with some tools that 3.5 doesn't come with, like advanced data analysis tools. That's what I'm using it for. If you look at GPT 3.5, you can start chatting with it, but there's no means of uploading a file. With GPT-4, there is. So let's do that. I'm going to attach this sales data that I have so I can start comparing data in ChatGPT against the data in SQL Server. So we'll just let this load. One thing about the size of the file is with OpenAI, you can upload up to 512 megabyte file. If it's bigger than that, you can zip it up, load it in here just like I am now, and it's smart enough to know it's a zip file, so it unzips it on its end. So that's pretty powerful stuff. Okay, it just finished that. There's 1 million records in here. Like I said, it's a CSV file. A CSV file can handle up to 1 million records, so can Excel. I've used Excel files in this too, and I found that sometimes when it's doing calculations, there's an error, and I don't really get that when I use a CSV file. So keep the file as simple as possible. CSV is pretty vanilla. That's, to me, the way to go. So now that the file is uploaded, let's ask it that question about the top 10 parts, like right here. So instead of writing a TSQL statement, we're going to just do regular natural language. So let's do that. Show the top 10 parts by quantity sold. And then we'll see this calculator. What's really cool about this, I can do this drop down, and you'll see it's using the pandas object, and this is Python code that it's generating itself to handle this task. This is really mind-blowing. I can copy this code and put it into a desktop app. If I'm using, in my environment, I use Visual Studio, so I can write a Python application using this code right here to do testing. So you can see the thinking of AI, how it's thinking and whatnot. This is where it's keeping that CSV file, and now it's operating against it. So it's done analyzing, and it's ready to output those values here. So now it's given us the top 10 parts by quantity sold, and that's what it's saying right here too. So that's pretty cool. So we'll let that load, and what I'll do is I'll bring up the SQL Server side so we can do a comparison, a side-by-side comparison. Okay, so on the left here is my SQL Server, and on the right is ChatGPT. So I can do a side-by-side comparison. I look at the first part, that's the same part here. The quantity in AI matches the quantity that I have in SQL Server. The next part, this is that same part number is here. The quantity is off though. It's about 2 million off. So what I did is I just said, okay, well, something's up with this part here. Let's do some investigation. Now I know what the problem is, so I'll show you what I did to find this. So I just went into our sales data, and I said, just give me all the sales where the part number is that part that I'm curious about. I just clicked in here, and I randomly paged down, just scanning data to see if visually if I see something strange, and I actually did. As you can see here, these are two different, although they're the same part in SQL Server. SQL Server doesn't care. Apparently the ERP system that this data was in doesn't care. Excel doesn't care, but I think AI does. It's somehow dropping, it's not seeing these as the same part. So another thing that I found in this part, if I copy it, for example, I look here and I see that there's a blank space at the end of this part. So we have possibly two problems. We have a case sensitivity issue, and we have trailing and possibly leading spaces on that part. Why? I don't know. But as a ETL programmer, something like that, now that I've discovered that, okay, these are kind of different, I would update my ETL code to update the part in this fashion. So this is the TSQL statement that would do that. Now, to find out if this would really help or not, I can actually go to OpenAI and continue asking it questions, but having it trim that. So I'm going to tell it to operate against the data set and remove those any leading and trailing blanks, and to make it uppercase, and see what results we get afterward. It has the file, remember, because we uploaded it. It's going to operate against it, and anything I tell it to do to manipulate that file, it's going to do. I can even then download that file back onto my desktop, but that's for a different video. So let's do this. I'll say remove any leading trailing blank spaces in the field in the part. Let's do that. Part field. Also make it uppercase. Now it knows when I'm saying make it uppercase, it knows I'm talking about the part field. That's how smart that's how smart the AI is. So I'm just going to go ahead and have it do this. So let's take a peek while it's working to see what it's doing. And it already knows. It's removing the leading and trailing spaces. And it's converting the part field to uppercase. It says it right there. That's what it's doing. And here's the code that it's using to do that. So if you ever want to know what the Python code is like for it to handle that task, this is it right here. It's just, it's mind-blowing. So it finished doing that, and what we'll do is we'll ask it the same question, and because I'm lazy and I don't want to type it out again, I'm going to just copy it from here and ask it the same question. And we'll just let it analyze that. So now it's coming back with the top 10 again. I am going to bring up the SQL Server results again, and let's do that side-by-side comparison and see if that cleansing that field helped. So SQL Server on the left, the first one matches. Now the second one matches. Right on the money too. Third one, perfect, perfect. Fourth, let's go to the last one, just to save time here. 105,877,705. It matches perfectly. So that fixed it. So now that I confirm that, like I said, I would put this into my ETL so it scrubs it before it gets to that CSV file. That's what's important here. So to summarize, what I'm trying to get across is, first and foremost, you need to denormalize your data. The data needs to be in a tabular form for AI to have a shot at understanding what you're doing. In my case, I had to denormalize from a data warehouse architecture. So if I look at, let's look at the fact table on this thing here. This is kind of beyond the scope of what I'm trying to do here, but this is the original data. So this is a fact table for sales. As you can see, almost everything is a key value lookup. Well, AI is not going to know what sales rep key 7 means. It may. You could probably upload this, and this is pretty private data. You could keep the privacy of your data if you just had these, and it would be returning results based on, well, your sales rep key of 7 has this many sales. So it all depends on how much you want to denormalize it. But I went from this to this. So now instead of a sales rep ID, like from here, I have actual sales rep name. Again, this is fictitious. These are fictitious names to maintain privacy, but that's what I mean by denormalize. I mean, just giving it meaningful names, including the field name, like sales rep or customer, instead of customer key and sales rep ID, that sort of thing. Also, if there's, your field name should be named something meaningful. Spell it out, don't abbreviate, et cetera, et cetera. Fields that you're not going to measure that shouldn't be in that file, ditch them, don't have them in there. You want this file as lean as possible. I had 10 columns in my data set, but I have 1 million rows, so that's pretty impressive. And don't data dump and chat. This is kind of where I think a lot of companies are heading, is they think now that AI is out there, like Microsoft Copilot, or even with this ChatGPT-4 or whatever tool that they're using, that if they can just export data from their ERP system without a database person or a data expert in between that path, that they can just dump the data and start asking questions, and that's simply not true. So once you get that file in the right format, upload it into your AI, start doing sanity checks, get some metrics to do comparison with, and like they say, trust but verify. And I use real world data too. I used my data was real enterprise level data. I didn't get it from Kaggle where it's only like 1,500 records or a couple thousand and it's just all pristine. This is data from the trenches, and it looks clean. It looks clean in SQL Server. Obviously, it was clean in the ERP system, but AI may not like that. That's why you have to do this sanity check. It's so important. And lastly, once you realize what needs to be clean, if you're doing what I'm doing, and that's generating these files or data for AI so you can chat with it, you want to have some process, some coding in there where you're cleansing that data before it gets to the CSV or Excel file or whatever file you're using to upload into AI. So scrub at the ETL level. That way you're not doing it at the AI level. You can go to AI like I just did in this demo and have it manipulate data and fix it, but I'm only doing that to see if that fix will work before I implement it on the back end in the ETL before it even gets to that point. So that's kind of what's important here. And lastly, if you have any data that you want to keep private, you can toggle that. You can what I call obfuscating the data to make it where it's still kind of meaningful to you, but you're not really looking at the real names. You can have that as a lookup in your database. So if you need to reverse engineer and say, okay, these sales reps I'm interested in, you need to kind of reverse engineer and see who they really are on your end. But if you're paranoid about putting data out there in the cloud and in an AI environment where machine learning could be taking place, you can consider that too. So that's it. Thanks for watching. So one of my videos that will be coming up, I plan on taking that data that I just uploaded into OpenAI and doing deep analysis. Now that I can trust it, I built the confidence that AI is looking at that data as I expect. I'm going to start doing some deep analysis. I'm going to generate graphs, charts, do trend analysis, all kinds of stuff. So that's going to come up. And then also I think I'm going to do a demonstration on taking that Python code and showing how to make a custom app, a custom desktop app using Python and an OpenAI API to make those calls instead of having and operate against that CSV file or your data source on your desktop instead of uploading it into OpenAI and chatting with it that way. So that's it. Thank you.